Hello friends, how are you? Hope you guys are all well. Welcome to my YouTube channel. Today my topic is, as you can see, that the contemporary state of the art electronic structure methods. Okay, so before moving to my topic, I request you to please subscribe my YouTube channel and don't forget to watch my previous videos because I have uploaded much more informative content that will help you a lot in your daily life. So moving to my topic, the contemporary state of art electronic structure methods abstract, the flash photolysis photoacoustic spectroscopy were used to study the bacterioadoption photocycle kinetics and the enthalpy changes associated with the slow intermediates of the bacterioadoption were evaluated from the photoacoustic frequency spectra. Simulation of the frequency spectra was performed on the basis of the blind photocycle. Introduction. Bacterioadopsin is the protein pigment complex found in the purple membrane of the Halobacterium halobium. Absorption of a photon by the light adapted from a form of the bacterioadopsin initiates a photocycle during the course of which protons are translocated across the purple membrane. The photocycle takes 10 seconds and several intermediates have been identified. Initially, the scheme was thought to be linear. However, the several papers have provided experimental data which supported a branched model with a pathway going from M412 to BR570 by passing. This paper describes the pH effect on the slow intermediates of the photocycle. Flash photolysis experiments were carried out to investigate the pH and the salt effect on the intermediate. The blind pathway model of the slow part of the photocycle of bacterioadopsin represents the fraction of M412 molecule which decay via 0660 K, I, K2, K3 as a first order rate constant. Intermediates K590, L550 were not considered in the model. Photoacoustic frequency spectra were measured in the 420 Hz range at the 3 pH. The kinetic and energy variations associated with the article published online by EDP Sciences and available at. Okay, so the intermediate formation were investigated. The pH frequency of the frequency spectra is similar to that observed flash spectrometry. The pH frequency spectra was stimulated assuming a blind photocycle. The enthalpy changes associated with the M412 and 0660 intermediates were evaluated. Materials and methods. Purple membrane fragments from Halobacterium halobium were isolated as previously described. They were suspended in buffers with or without 4M NaCl. For flash photolysis measurements, membrane suspensions were illuminated with a flash tube. The flash induced absorbance changes were followed with an analytic light beam provided by a Varian 300W xenon lamp. After passage through a monochromator, it was detected by a photo multiplier and stored in a CAT computer. Usually 70 flashes were added. All measurements were performed at 230 C. The pH spectrometer were described elsewhere. 6. The pH signal was measured on the purple membrane suspension 0.75 mm using a monochromatic light beam which correspond to the bacterial hodocin absorbance maximum 570 Newton meter. The chopping frequency was varied between 5 and 420 Hz. The photo inactive reference sample was a bleached suspension mixed with a black ink in order to match the optical and the thermal properties of the photoactive sample. The log-in amplifier was, you can say that was sample. This phase setting was researched by for the recording the signal from the photoactive samples. Simulations were performed as described elsewhere. Results and discussion. Flash induced absorbance changes were measured on the purple membrane suspension at 660 Newton meter in the 5 to 9 pH changes. This wavelength correspond to the maximum absorption of the intermediate. Figure 9. Effect of the pH on O dependence on the decay rate constant and of the maximum absorbance. Buffer 0. buffer with 4 meter and NaCl, the A max value at pH 5.1. No salt was used for the normalization. Responses were similar to those previously published. The accordance reaches a transient maximum. Okay, so I think this is enough for today's topic. So time to go. Goodbye. Meet you in the next video.